Hello, my name is Scarlett Urban, and I did an experiment on testing the different nutrition levels of ammonium nitrate and sodium phosphate on Arthrospira platensis, also known as spirulina. My question is what level of ammonium nitrate and sodium phosphate concentrations allow for the best growth of spirulina? I hypothesized that the highest amount of concentration would present the best growth. So my methods were that I made the concentration and added CO2 tubes and artificial light for the Erlenmeyer flasks so that the algae have the best growing potential. And this was over a span of 2 weeks, and I measured 2 times a week using the spectrophotometer to measure the absorbance rate. And I collected other calculations and recorded everything, and I did this for 3 trials. My data showed that actually everything was opposite of my hypothesis, and the concentration with the least amount presented the best growth. As you can see in the pictures in figure 1, the second from the right is the least amount and has the best growth. This is 1 week in, and 1.5 weeks in is the other picture, and you can see a little bit of growth. So my conclusion is that my hypothesis was not supported by my results, as the solution presented the most growth was the solution with the least amount of ammonium nitrate and sodium phosphate. And in the future, I can adjust these procedures and carry out a different experiment that uses this information. During this whole process, I had a lot of help from my teachers, classmates, and parents. Through providing the algae for me and the support, and helping through trial and error of my whole experiment. They helped me understand how that I need to use CO2 pumps rather than magnetic stirrers, and how to use artificial light versus just the natural light to get more growth faster. And my classmates helped to provide support and teach me how to use the spectrophotometer properly. And my parents helped me take care of my algae while I was at home over winter break, and they regulated the artificial light for me when I was gone. So during the experiment, I did have some strengths and I did have some weaknesses. The strengths is that the Erlenmeyer flask created a perfect environment for the algae, as well as the CO2 pumps and the artificial light, creating the great environment for the algae. But I did have to purchase a 50 milliliter of algae, of the spirulina algae, when I only needed 40. So there was just some extra left over that I didn't need. And the spectrophotometer and cuvettes were difficult to work with, and I had to get help from my friend to understand how to use it all. And I needed the zip ties to hold the tubes, the CO2 tubes, in place, because they would just fly out if I didn't have them. So I used those. And so the importance of my entire investigation is it's a gateway for future projects that I will be working on. In the future, I will be looking at how to engineer ways to minimize this eutrophication. And it's a good way to see the effects of nitrogen and phosphorus have on algae, and how that can relate to the real world is how algal growth is impacted by stormwater runoff. And it helps to spread the knowledge about stormwater runoff and how bad it can be for our environment. Lastly, an unexpected outcome was basically the whole thing. I had to redo most of it, from the magnetic stirrers to the CO2 pumps instead, and I had to change my algae species because I was originally gonna use Spirulina, but I couldn't use that because it wasn't a uniform algae all throughout, while spirulina is, and everything went wrong. So I had to retry at least 3 times, and it was a crazy experiment, but we got here. And even though it's still incorrect technically, there's still numbers. So I'm really grateful for this project.